Can you name all the planets in our solar system in their correct order? If you counted 8, congratulations. That seems to be the correct answer. But what if I told you that you might have missed one? There might be another planet, 10 times the mass of the Earth, lurking in the distant reaches of our solar system, a planet so far away that it has never been directly observed. Could it be a rocky planet, a gas giant, or even a planet from another star? Perhaps it could even support alien life. In recent years, scientists have uncovered tantalizing evidence that suggests our solar system might not be as complete as we once thought. The Kuiper Belt, a vast band of asteroids situated well beyond the orbit of Neptune. Most of these asteroids follow a circular orbit around the Sun, but small groups have revealed strange gravitational anomalies that challenge our current understanding. Anomalies that can't be explained by the objects we already know about. These anomalies suggest the presence of a massive unseen object exerting its influence from afar. Asteroids are orbiting perpendicular to those of the planets, moving in the opposite direction around the Sun, unlike most objects in the solar system, and clustering together. The combined effect of these orbital anomalies strengthens the case for Planet 9's existence. Astronomers were so convinced that the existence of a planet so far out was so preposterous that they were determined to disprove this theory using supercomputer simulations. The simulation came as a surprise for the astronomers, as it not only matched the orbits observed for those asteroids, but also predicted even stranger orbits that should have occurred but haven't been observed yet. If they can find the orbits predicted by the simulation, it will almost certainly prove the existence of Planet 9. And then they found it. The discovery of asteroid 2012 DR30, accurately predicted by the simulation, has strengthened the belief in the likely existence of a real Planet 9. It's nearly certain that Planet 9 exists out there. However, for absolute certainty, astronomers need to locate it. The challenge lies in its great distance, making it too faint to detect. Planet 9, if it exists, is a master of disguise. It lurks in the outermost regions of our solar system, hiding in the vast expanse of space where light barely reaches. This is not the first time astronomers have used gravitational anomalies to infer the existence of a hidden planet. The history of astronomy is filled with such detective work where unseen forces have led to groundbreaking discoveries. In the 19th century, the irregular orbit of Uranus led to the discovery of Neptune. This historical precedent gives credence to the current search for Planet 9. Just as Neptune's gravity subtly tugged on Uranus, astronomers believe Planet 9's gravitational influence is responsible for the peculiar orbits of these distant Kuiper Belt asteroids. But Neptune was relatively easy to prove. Planet 9, however, is a different story. It's 20 times farther than Neptune, residing at the very edge of our solar system. If Planet 9 is indeed out there, it's many times farther away than all the other planets combined. How can we possibly find a planet so distant? What does it look like? What is it made of? Is it an Earth-like planet or a water world? Until we gather more data, we can only speculate about the planet's composition. Based on the gravitational influence observed on the Kuiper Belt objects, astronomers have been able to estimate some of Planet 9's potential characteristics. Calculations suggest that Planet 9 is 10 times more massive than Earth, with a radius approximately 4 times that of Earth. Many other solar systems have a super-Earth planet in their system. Perhaps Planet 9 is our super-Earth planet. If this is the case, it should trap geodynamic heat similar to Earth, but with 10 times the mass. It would be significantly hotter than Earth. Additionally, being located at a considerable distance from our solar system, it should also be very cold. As an Earth-like planet, we can expect an Iceland-like landscape on steroids, a mix of ice and lava captured within the planet's internal heat. Volcanoes, mountains, canyons, and plate tectonics could all be part of its features. The gases emitted from the volcanoes should swiftly revert to ice upon contact with the atmosphere. It could be an exquisitely unique landscape out there if only we could find it. But how did this planet form? If that super-Earth really exists, something doesn't add up. There wasn't enough rocky material for a planet that big to exist alongside all the other rocky worlds we have today. So maybe it isn't a rocky planet after all. The combination of its large mass and vast distance has led astronomers to believe that Planet 9 is likely an ice giant, similar to Pluto. In the outer solar system, an ice giant with 10 times the mass of Earth would have icy geysers piercing through the frozen surface. However, the most intriguing aspect may lie in its underwater world, potentially making it the farthest planet with liquid water. As we examine our solar system, we discover the rocky worlds closest to the Sun, followed by the gas giants, and then the icy expanse of the Kuiper Belt. While these asteroids contain some rock and other materials, they are primarily composed of ice. What if Planet 9 is the larger sibling of Pluto? Pluto was once considered the 9th planet, but in the 1990s, a multitude of icy worlds similar to Pluto were discovered. This led to its reclassification as a dwarf planet. So, could Planet 9 simply be the largest member of the Kuiper Belt's icy objects? If this is the case, even without the warmth of the Sun, a celestial body with 10 times the mass of Earth should generate heat due to its extreme gravity, potentially giving rise to ice volcanoes instead of molten rock. If this is true, it could become the largest water world in our solar system. But yet again, we observe many dwarf planets similar to Pluto, which is much smaller than our moon. Given the limited material available to build even a small planet out there, the mystery remains. How does Planet 9 have 10 times the mass of the Earth? Perhaps Planet 9 didn't form in the same location where it is today. Maybe it originated in a vast, gas-rich region in the middle of our solar system, akin to a sibling of Jupiter, Saturn, Uranus, and Neptune. If this is the case, how did it end up so much farther away than its gaseous siblings? In fact, in 2011, scientists attempted to simulate the formation of our solar system and failed. It was only when they added another gas planet that they were able to replicate our solar system. Furthermore, in their supercomputer simulations, this planet was ejected from the solar system by the gravity of Jupiter. Could the answer to this question already be found in computer simulations? If this is the case, Planet 9 could be the contender that lost in the competition to become the Jupiter gas giant. And yet, many scientists believe that Planet 9 never formed in our solar system to begin with. What if our Sun got so close to another solar system and simply stole one of their planets? We have already proven that our solar system has stolen comets from other stars, so if these objects can arrive from alien solar systems, is it also possible for planets to do the same? Unfortunately, to answer all these questions, we will have to test its chemical composition to determine whether it formed here or elsewhere. However, before launching a probe to test its materials, we first need to find it. Scientists believe that by using math, they can predict smaller areas in the sky where Planet 9 should pass. For now, we are keeping a close eye on the constellation Orion, using infrared telescopes such as the Hawaii telescope, which can detect heat in the cold expanse of space. However, don't hold your breath. It could take years until we find Planet 9. As soon as we do, we will be able to observe its light and gain insight into its atmospheric compositions. This will help us determine if it's a rocky world, an icy water world, or a gas giant. If it's out there, it may also have moons, and perhaps one of them could even harbor life. What if we haven't found the planet because it doesn't exist at all? All we do know is that there is something out there, invisible to us, with a mass 10 times that of Earth. What if this massive anomaly is invisible for a reason? We are delving into pure speculation here, and it can be quite intimidating. But the possibility of Planet 9 actually being a black hole has been a subject of scientific speculation. Some astronomers have proposed the intriguing idea that Planet 9 may not be a planet at all, but rather a primordial black hole, potentially the size of a grapefruit or even smaller. This hypothesis has sparked discussions about the potential implications and methods to determine the true nature of Planet 9. Researchers have suggested that the anomalous orbits of trans-Neptunian objects and excess microlensing events could be explained by the presence of primordial black holes, aligning with the Planet 9 hypothesis. If this is the case, what is the impact on our planet? We still don't have all the answers, but one thing is certain: we definitely don't want to encounter a black hole. To learn more about rogue black holes that could potentially sneak up on us, watch the next video.